Welcome back, Hampshire chemistry students. In this video today, we're going to be taking a look at a discussion on stoichiometry, and our goal of our overall video here is that we can do a multi-step stoichiometry conversion. So we're going to start simple today and make sure we're building up those skills for how we understand to set up and do the converting of units. Remember, that's what stoichiometry is going to mean. So we're going to be taking a look at a reaction and a few different problems. Okay, so I recommend trying to get some of these guys down here. I got one problem that's hiding down below that we'll see in just a second. But you can see that we are starting off with a word equation where it talks about aluminum is left out in the open air. It will eventually synthesize with oxygen to form aluminum oxide. So some key things to remember here when you're setting up an equation. Make sure we're picking out those chemicals, right? We've got aluminum. We've got it reacting with oxygen gas. And then we've got aluminum oxide. So we're going to have some ALs and some O's combined together. And we have a key here that says, hey, this is to form. So these two are synthesizing to make this guy. So let's go ahead and set up and write out that reaction a little bit here. I've got Al plus oxygen. Now those of you guys who are remembering your diatomics are probably screaming at me right now to make sure that I use a subscript 2 for oxygen. So that way it will react and form correctly. Now we then need to think about our aluminum oxide. So some of our key tips here when we're balancing and writing equations is we always want to make sure our compounds are correctly made. All right, so that's why I make sure to remember my diatomic rules for O2. Now with aluminum, aluminum has a charge of +3 on our P table. Oxygen has a charge of -2. You got to make sure you're considering those pluses and those minuses when you're setting up a compound. So I'm going to know that I'm going to need 2 +3s and 3 -2s to help me cancel this out. So my final formula here is very simply going to be Al2O3. Right? So that is our compound with our correctly made formulas. Okay? But then we need to make sure we go ahead and balance with the correct coefficients. So, for example, I noticed that I have two oxygens on the left and 3 on the right. So in order to get those to balance, I'm going to need to get both of them to 6. So I'm going to need 2 aluminum oxides, which means I have 2 times 3, 6 oxygens, which means I need a 3 here. Now I'm going quickly here, but this is a skill that will come back to us as we get more practice with it. Okay? And we can see that we have 2 times 2, meaning 4 aluminums on the right. So we're going to have 4 aluminums on the left-hand side as well. Now we have that correctly balanced equation. If you ever find yourself getting stuck to the point where you can't balance either side, you've tried over and over again, it probably means that you might have forgotten or gotten an incorrect formula as part of your compound. But so, let's use this knowledge here to help us set up and solve a problem like number 1. Number 1, it says that we're taking 15 moles of aluminum, and reacting completely to create how many moles of aluminum oxide. So I need to take my moles of aluminum and convert them into moles of aluminum oxide. Now, I usually write any one of these guys out, and I think of it as my plan. It's my roadmap for how I'm going to do my conversion. Okay? I'm going to get a mole-to-mole conversion here using my balanced equation. So let's set up our units. I have 15 moles of aluminum. I'm going to multiply by a fraction, and I'm going to make sure I have moles of aluminum on top, so that's what's going to go on the bottom here. And then I'm going to be placing my unknown when I'm trying to find my moles of aluminum oxide. Now, I then need to pull in my coefficients from my nicely balanced reaction. Remember, because what this is telling me is that for every 4 moles of aluminum, so I'm going to put up 4 down here, I get 2 moles of aluminum oxide on there. So my way I'm going to figure out and cancel out my units of moles of aluminum is I'm going to take 15 times 2 divided by 4. My answer is going to be 7.5, and my new unit is going to be those moles of aluminum. aluminum oxide. So a mole to mole conversion is very simple. As long as you have a correctly balanced equation, you will get the correct answers. If you're having trouble getting an answer here, that probably means that one of your coefficients is wrong, meaning that your balanced equation is wrong. Now, let's take a look at a trickier one here, because this is just a simple one-step, moles to moles. When I look at a problem like number 2, you can see that we're starting with, this time, with liters of oxygen. And it's reacting with excess aluminum, and we're trying to figure out how many moles of aluminum oxide are formed. So we are ending with moles again, but this time we are not starting with moles. So we're going to need to think back to some of our different conversions we've used before, right? That 1 mole equals 6.02 times 10 to the 23rd molecules equals 22.4. Liters at STP equals grams in molar mass. I can see here that if I'm starting with liters, I can convert it to moles, and then we can do what we did in step number 1, do a mole to mole conversion. So my plan for this problem is going to look a little bit like this. I want to get my starting stuff into moles. So I want to turn these into moles of oxygen, and then convert the moles of oxygen into what we're trying to find, the moles of aluminum oxide. So you can see here each arrow is going to be a represented step in my problem. So let's set this up and let's write out our work. 43.5 liters of O2 is going to get multiplied. Okay? Now, each arrow is essentially going to remind myself that each one's going to become a line, become a step in my problem. I'm going to put those liters of O2 on the bottom, and then I'm going to put what I'm trying to find in my first step, my moles of O2 on the top. So this is just like our mole conversions homework in our first step. So let's go ahead and plug in some numbers here. We know that for every 1 mole of a gas, there are 22.4 liters at STP. So 22.4 gives me 1 mole on the top. I can see that my units will cancel. And I'm going to take that 43.5 divided by 22.4. I'm going to get 1.94 as my answer for my moles of O2. Now, I could go ahead and round here, but ideally when you're doing any kind of conversion problem, you only want to round at the very, very end. So I'm going to round in my paper here, but I'm going to keep this nice long number in my calculator and use it here in just a second. So let's keep going as our next step, our second step here, right? So this represented our first step. And now we're going to take a look at that second step here, to convert our moles of O2 into moles of aluminum oxide. This is where we're going to need to take into play some of those mole ratios we made in our balanced problem. So matching my units. I'm going to look back up at that nice handy-dandy equation we have. I have 2 moles of aluminum oxide for every 3 moles of oxygen. I ran a little bit out of space here, but we can squeeze in our final answer. I'm going to keep that number in my calculator. I haven't rounded it fully. I'm just going to multiply by 2 and then divide by 3. That cancels out the O2 and leaves me with my aluminum oxide, and my answer in this case as 1.294 and so on. I'm going to round my answer to 3 sig figs, so 1.29 moles of aluminum oxide. Okay. So 1.29 is my final answer. Whew, 2 whole steps of math. Okay, these are going to get a little bit tricky, but it's using all the skills we've done before. We just converted liters into moles and then used our new skill of doing our mole to mole conversions. So let's take a look at that final problem here, number 3. If you've already taken a look at this one, you might notice it's got some extra stuff in. It's got some scary stuff in here, or at least scary looking stuff, because you'll notice we're starting with atoms of aluminum oxide, but then we're asked to find not moles of oxygen, but grams of oxygen. Uh-oh. All right, so we're going to have to do a multi-step problem, and this you might already be able to figure it out. It's going to be 3 steps because I'm going to take my atoms of aluminum oxide. I'm going to convert those into the moles. I'm going to need to do a mole-to-mole conversion. Then once I've got my moles of aluminum oxide, I'm going to convert those moles of aluminum oxide into moles of oxygen because I'm trying to figure out the grams of oxygen in the end. Then once I have my moles of oxygen, that's when I'm going to finally turn those into grams. Whew, and finally find our answer. And you'll see here I've got 3 arrows. That means I'm going to need 3 steps to do my entire conversion. Now you might have noticed that I actually ran out of space here when I only did 2 steps. So I'm going to actually condense my work here and do these all in one long line of math. If it feels better for you to still do the 2 steps separately, that's fine. But watch and try my method out here for this example. So I'm starting with my 4.56 times 10 to the 25th atoms of aluminum oxide. And I'm going to multiply by a fraction here. That'll be my first step. And I'm going to take my atoms of my aluminum oxide, and I'm going to want to convert those in our first step into moles of aluminum oxide. Okay. We already know and can think about our conversions here, right? That 1 mole equals that Avogadro's number, that 6.02 times 10 to the 23rd. So 1 goes on the top with moles. 6.02 squeezed in here a little bit times 10 to the 23rd. Trust me, it's down there. It's a little tiny. So I could type in my calculator and figure out my answer here, but I'm just going to keep my math rolling as a separate step. Because now I want to take my moles of aluminum oxide and convert them into moles of O2 on the top. This is going to come from my balanced chemical equation, which we can go back up to the top and find 3 moles of O2 on top this time rather than on bottom before, and in this case 2 moles of aluminum oxide. So that is our second step of math. Notice I haven't plugged in anything in my calculator yet because I still have a final step. And I want to convert these moles of O2 into grams of O2, our final answer. This is where we're going to use our final conversion we haven't talked about yet. I'm going to take, I know that 1 mole is equal to the molar mass in grams of any chemical. So I need to figure out the moles of O2 and how many grams there are in 1 mole. Thankfully, I know that oxygen is just 16. You could always check on your P table, but trust me, it's correct. And we have multiply that by 2, and we get 32. So for every 1 mole of O2, I have 32 grams of oxygen. So you can see my 3 steps here. We can check back in our units, right? Because our plan was to do atoms of aluminum oxide to moles of aluminum oxide. Moles of O2, then into moles of O2 and grams of O2. So here's our atoms being canceled out in our first step. Here's our moles of aluminum oxide being canceled out in our second step. Here's our moles of O2 being canceled out in our final step and giving us our answer in grams. So let's plug and chug into our calculator. It's a lot of math, but it's all in one step. 4.65 times 10 to the 25th times 1 divided by 6.02 times 10 to the 23rd times 3 divided by 2 times 32 divided by 1. So I have 6 different numbers that I'm multiplying or dividing by, and I get a final answer here of 3,707, which I want to round to 3 sig figs. So my answer is going to be 3,710 grams of O2. Squeezed in there a little bit, we can see how we set up all 3 of our steps. Now, I want to look back at all of our work. Okay? In each and every single one of these problems, we included this one type of the same conversion, and that was a mole-to-mole conversion. And if we look back up here, right, in our first example, we had a mole to mole conversion. In our second step, we also had a mole to mole conversion. And in our third step, third problem, we also had a mole to mole conversion. Every single Stoich problem is going to include a mole to mole conversion. Why don't we go ahead and remind ourselves that here as the top is our final let go here. That all Stoich problems involve a mole to mole. Okay. So we can use those and help us set up all of our different problems today. This is something that takes a lot of practice, and that's okay. We're going to be getting a lot of practice at this here together, but there's our examples to get us started. Have a great rest of your day, guys, and I'll see you next video.